Hi, in this video we're looking at something called binary covalent compounds. Now we just got fresh off of doing a ton of ionic compound videos, looking at multivalent metals and polyatomic ions and what happens if it's just a regular metal with a nonmetal. All of that is all for ionic substances. What we're now looking at is covalent substances. And as a refresher, covalent substances are substances that only contain nonmetals. Binary means two parts, just like it did with binary ionic compounds. That was just a metal and a nonmetal. Binary covalent compounds are just two nonmetals. And actually, I think students tend to find this to be a little easier to name and to write formulas for, so let's jump into it. First, here's our unit outline. We've completely covered ionic at this point, which is what I was just talking about. But now we're here in covalent, and we're looking at these binary compounds in the covalent section. So here's the general formula, but I want to add something to it. So if you're writing, don't write yet. There's two nonmetals in a binary covalent compound. The first nonmetal in the formula would just be named normally. The second nonmetal in the formula would get a nonmetal-ide name. That's that IDE ending that we reviewed when I introduced you to naming and formula writing. But because covalent substances don't get charges like ionic substances do, we just simply put prefixes in front of the nonmetal names to tell how many atoms of each nonmetal there are in this substance. Here are the prefixes. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 hepta, 8 is octa, 9 is nona, and 10 is deca. Now we'll come back to those prefixes in a second, but there is kind of two exceptions to this. Of course there are, it's chemistry. One exception is that if you ever plan to start a name with mono, in other words, if the first nonmetal starts with mono because there's only one atom of that first nonmetal, don't do it. Just leave mono off. The only time you'll use mono as a prefix is on the second nonmetal, the nonmetal-ide name. So that's one exception. The other thing is this. If you've got a prefix that ends in O or A, so I'm talking about these ones here, and you plan to use that prefix in front of oxide, so for example, dioxide, monoxide, instead what you would do for those O and A ending prefixes, the ones I've highlighted here, you just want to remove the vowel on the end there. So carbon monoxide, not monoxide. Carbon dioxide's okay, trioxide's okay. But if it ends in an O or an A, which is all of them on this list except for 2 and 3, if it ends in O or A, you just want to drop that O or A off. Only reason for that is actually just so it flows a little better when you pronounce it. That's really it. So let's do a couple of these. Let's go from name to formula. First, if I had sulfur dichloride, that would be SCl2. I know this because sulfur at the beginning does not have a prefix, so you would think that that would have to be 1 then. So this is what tells me this is 1 sulfur. And then di, the prefix di means 2. So that's how I know it's SCl2. Again, we don't write prefixes, or we don't write subscripts for 1, so that's why it's just SCl2. Here's another one, boron trifluoride. Boron is B. There's only one of them, just like in the last example. Not putting a prefix at the very beginning of the first nonmetal means that there's only one. But then tri means 3. So that means this is going to be BF3 for the formula there. And here's another. Tetraphosphorus decoxide. So tetra means 4 phosphoruses, so P's. And then deca, in this case, dec, because it's in front of oxide, deca means 10. So this is 4 phosphorus atoms, 10 oxygen atoms, so P4O10. Here's another one. This says dinitrogen pentoxide. This would be 2 N's, di means 2, and then penta is 5. Again, we just dropped off the A on this because we were naming an oxide, so this would be N2O5. Okay, what if I went in the opposite direction? What if I went from formula to name? Well, with ionics, sometimes this would cause more issues or more difficulty. But for binary covalent compounds, it's actually not that bad in either direction. Here's what this would look like if I had SO3. Well, this would be one sulfur. Normally you'd think I'd put monosulfur, but I'm just going to drop off that mono on the first one. And then there are 3 oxides, so trioxide. So this would be sulfur trioxide. Here's another one. This one's CCl4. Again, no monocarbon, just carbon. And then 4 is tetra. This part here, we'd use the prefix tetra. So this would be carbon tetrachloride. Okay, here's another. This is SF6. This stuff is actually kind of cool. You breathe it in, it makes your voice go much lower. It's kind of the opposite effect of helium. SF6 is sulfur hexafluoride. Having 6 atoms would result in a prefix of hexa. Okay, and no, this is nitrogen monoxide. Now I want to pause for a second here. Notice I do use the mono on the oxygen, but I don't on the nitrogen, and that's simply because nitrogen comes first. I would not start this by saying mononitrogen monoxide. It just doesn't happen. It's one of those exceptions. All right, last example, B2H6. This is diboron hexahydride. Okay? So back to our unit outline here. We are now able to check off binary covalent compounds. It's just that simple. The issue with this is that a lot of times students will think that they can name ionic substances this same way because it's much simpler than naming most ionics. And that's obviously not correct. There's a different set of rules for naming ionic substances. So don't fall into that trap. Thank you.